So this is edexcel further statistics 1, chapter 5, central limit theorem. We can start from number 2. So first side, six-sided dice numbered 1, 2, 4, 5, 7, 8, rolled 20 times. So this is fair. So we need to know what is the mean and standard deviation. So let me calculate it with calculator. You can add them all together. And 1, 2, 4, 5, 7, 8. You can add them all together and divide by 6 to find mean. And my case, I like to find the variance with the mean of squared minus the square of the mean. So now I just calculate it like 1, 2, 4, 8 over 6 becomes 4.5 and 1 squared, 2 squared, blah blah blah, a squared over 6 minus 4.5 squared becomes 2.5. No, I mean squared, because my calculator gave me the standard deviation, but this is the equation for the variance. So now, anyway, now we know this might be following the distribution of by the central limit theorem, distribution of the normal distribution with the mean 4.5 plus comma 2.5 over square root of 20. This is standard deviation. So this is the one we look for. This, let me write it here again. 4.5 comma 2.5 over square root of 20 squared. And we want to know what is x bar is less than 4. So we can calculate it with normal CDF. Yeah, we cannot find it from the, because the table doesn't show, it's difficult. So normal CDF. Lower bound is negative 999, upper bound 4, mean 4.5, standard deviation 2.5 over square root of 20. And the answer is 0.1855. And number 3. Sample of size n is taken from a normal distribution with mean. Okay, so x bar is following normal 1 comma 1 square root to n squared. Minimum sample size such that probability of sample mean being negative is less than 5. So probability x bar less than 0 will be less than 0.05. So this is what we want to know. So here, when we try to know here, maybe here should be 0, here is 1, and this part is 0.05. So we need to use the z-score, like 0.05 for the z-score. So negative infinite to z, so 0.05, the smaller than 0.05. might be so our side we need to see this one 1.65. So negative 1.65, 0.05, negative 1.65. Yeah, because it doesn't show the negative side. So we can think about like here until here. This is 1.65, and we can tell this is 0.9505, which means 0.1 minus 9505 means 0.0495. So because this is symmetrical, so by the symmetricity, so we can tell the other opposite side, there will be negative 1.65 as a z-score. So z-score is negative 1.65. So the z-score is x minus mu. So we know x is 0 minus mu over sigma becomes negative 1.65. So negative square root to n is negative 1.65. So n at this moment is 1.65 squared. So 2.7225. So it should be more than 2.7225, which means minimum sample size should be 3. N is larger than 2.7225. And anyway, n is a sample size, so it should be positive integer. It can be 0, but anyway. So n can be from 3. So the smallest possible n is 3. Number 4. Group of 20 students first exercised the dice 10 times and recorded the number of 6. So 20 students, each 10 times. So this is binomial theorem. Each of them has 10 and 1 over 6 because we just record the 6. So mean is 10 over 6 and standard deviation here 10 over 6 times 5 over 6, so 50 over 36. So this is the mean and standard deviation here, but we know, oh, I cannot make it. Okay. Yeah, like this. So, oops. Yeah, I'm always confusing here. So here. So now X bar is following. Now we have 20 samples about it. X bar is following normal distribution, 10 over 6, comma, 50 over 36, square root 20 squared. And we want to know the greater than 2. Probability X bar is greater than 2. So let's make it the binomial CDF. Oh, sorry. Binomial CDF. Normal CDF, sorry. Normal CDF. Lower bound 72, upper bound 9999, mu 10 over 6, and standard deviation 50 over 36 over square root 20. So this is the one. Oh no, I mean not 72, it's 2. I just confused my letter handwriting. So 0.1416. So this is the answer. So let's go for the next one. Oh no, I think I made mistakes because this is not standard deviation. This is standard deviation like this. Oh. So here, don't make mistakes like me. So standard deviation is square root 50 over 36 times 20. So this is standard deviation. So Let me make correction. Yeah, not so much different, but 0.10295. And number 6, married couple plan to have children and desperate to have a daughter. They decide they will keep having children until they have a daughter. So this is geometry distribution. So now we will find the probability it'll have more than 2 children. So let's call this x geometry, and this is equally likely, so 0.5, and probability of x larger than 2. So when we make this larger than 2, we know the formula 1 minus 0.5 squared, so 0.25. There are a group of 10 couples all decide on the same plan. So between them, 10 couples have more than 24 children. So 10 couples have more than 24 children means each couple can have like more than 2.4 children. So x bar may follow the normal distribution. When geometry series is 0.5, the mu is 1 over p, so it's 2, and the variance standard deviation squared is 1 over p, 1 minus p over p squared. So again 2. So now we can tell this is following is 2 comma square root of 2 over square root of 10 squared. So now we are thinking each of them separately, like 10 samples. So probability x bar may have more than 2.4 average. So this is what we count, and the distribution normal CDF 2.4, 9999, mean is 2, and 5. Yep. So when I calculate it, it is 0.1855. Number 7, the mass of egg normally distributed, mean 60 and standard deviation 5. Calculate the probability mean mass of an egg randomly chosen crate is greater than 59. So this is just a simple calculation. So greater than 59. So this is just normal. So x bar is following normal distribution of 60 over 5 over square root of 48 squared. So probability x is greater than 59. X bar. So normal CDF. 59 to 9999, mean 60, square root 5 over square root 48. So 0.91707. State with the reason whether your answer is an estimate. This is whatever it could be estimated, but this is because we found the sample is from the normal distribution, the population who follows normal distribution. So so this is not estimation. So because estimation, in this question, I think estimation is asking about like binomial estimation, Poisson estimation, something like that. But this now we just follow normal distribution, so it is not estimate. So number C, double York and we have 30. So this is binomial. So now this is estimate. So sample of 30 crate is taken. So each egg, because now we have 48 egg in the, so this is binomial 48, 0.1. So mu is 4.8. So standard deviation squared is 4.8 times 0.9. So 4.32. So now we can check 30 crates. So sample size is 30. So binomial, X bar is following. Yeah, let's call it Y bar because we already used X bar. So Y bar is following normal distribution, which has the mean 4.8, comma, square root 4.32, and square root 30 squared. And we want to know fewer than 150. So let's do that. So distribution, normal CDF, negative 999 and 150 upper bound, and 4.8, and standard deviation is square root 4.32 over 30. And no, again, so because sample with 30, so each of them may have 5. Because if this is 4.8, then we can say just each of them, the mean could be 5. So yeah, because just now I got the result of 1. So actually it doesn't make sense. 4.8 is the mean and I just calculate less than 1.5. 150. That's why. So 0.6996. So this is the answer. So let's go to the number 8. Automatic coffee machine uses milk powder. S is following. Semi-skimmed milk powder is sold 500 gram pack. Okay. So probability 1 pack will be sufficient for 100 cups of coffee. So we have this sample size of 100. So S mean will be follow 4.9, comma 0.8 over square root 100 squared. So this will be the distribution. And we want to find probability S is sufficient. This is 500, now 5. So sufficient means 5. Like larger than 5 or equal to 5, doesn't matter. So 500 gram pack. So sufficient means mean is smaller than 5. Each pack. So then in that case, when we add sum, then 500 grams or less. So here, distribution, a lower bound and upper bound, which is 5 and 4.9, 0.8 over 10, 0.08. So 0.89435. Number 9, random sample of size n is to be taken from the mean 90, variance 9. So minimum, okay. So x bar is following normal 40 and 3 over square root to n squared. So minimum sample size, does being greater than 42 is less than, greater than 42 is here, 0.05. So this is the one. We just found 0.05, 1.6 something. Yep, 1.65. Yep. So 1.65. So x minus mu over sigma will be 1.65. So this is minimum sample size here. So here 2 square root to n equals 1.65. So square root n is 1.65 times 3 over 2 n squared. So n minimum n is 6.125, means n cannot be the decimal place. So the minimum could be n is 7. So minimum sample size is 7. To make this 0.05 greater than 42. So number 11. Nationwide poll asked 500 people whether they prefer white chocolate or milk chocolate. So polling company prefer milk chocolate differs significantly from 60%. So polling company assume population 60% prefer milk chocolate. Okay. And defines random variable x is taken, value 1, and select number of population preferred milk and 0 otherwise. So x be the number of people who answers when. So describe the distribution of x and state mean n. So now we have the options of 2 answers. So when we consider the distribution, x is possible x is 0 or 1, and probability of the answer, the 1 is 0.6, 60% and 0.4. When we have this distribution, we can find the mean. So 0.0,4 plus 1 times 0.6, so 0.6. And standard deviation or variance. And 0 squared, 0.4 plus 1 squared, 0.6 minus 0.6 squared. So sum of, the mean of squares minus squares of mean. So now when we calculate it, no need to consider this, 0.6 minus 0.36, 0.24. So this is variance. So we know now standard deviation. So now we have expectation, mean, and variance. So modeling the poll as a random sample size of 500, estimate the probability differ from 0.6 by 0.03 or more. So it means from 0.57 to 0.63. So let's calculate it. So x bar may follow the normal distribution of 0.6, square root to 0.24 over square root to 500 squared, and probability of x bar is between 0.57 to 0.63. So binomial normal CDF 0.57 to 0.63, 0.6, and square root 0.24 over 500. And the answer is 0. But it is like or more, differ from 0.03 or more. So actually it's smaller than 0.57 and larger than 0.63. So just now I calculate this one, which is 0.829. So I'll subtract it from 1, then 0.1709. So this is the number B. So just now I calculated different from 0.03 or more. But now this question, number C, is differs from 0.6 by m most 0.03. M most, so it is asking about this one. So probability x bar is 0.05. Let's call it y bar because we already use 0.57, 0.63. This is greater than 0.05. So like this, and y bar is following normal distribution 0.6, comma square root 0.24 over square root n squared. So this is the one. So let's do that. So here, anyway, the mean is 0.6 and this is 0.57, 0.63. So we want to know about here. But now we have the table which is on the right side of the mean. So let me express this a little bit different way. Like 0.65 when probability x is smaller than 0.63, sorry. Minus 0.5 means here, right? Because this is the mean. So when I multiply them together, this will be larger than 0.05. So this is what I think. So probability x is, no, I mean not x, y bar, this is also y bar, 0.63 is larger than or equal to 0.025, 0.525, like this. So x minus mu over sigma, which is g-score, so 0.65 minus 63 minus 0.6 over square root n square root 0.24 larger than for this z-score 0.525 is 0.06. So yeah, 0.525 is 0.06. So 0.03, 0.06 times square root n 0.24, and 2 square root n is 2 square root 0.24. Oh, but this is too small number. So 2 times the square root 0.24 squared, 0.96. Because n is the sample size and is larger than 1 doesn't make sense. No, I mean greater than 95%. Why I made it 0.95%? So because of the stat test, Whenever I see the 95%, I always think it's 5%. So 0.95 over 2 plus 0.5. So this is how much? This is 0.975. So let's do that. 0.975. But smaller than 0.97, I mean larger than 0.975. So, 0.975 is 1.96. So here can be 1.96 on the right side. So when we calculate it, 1.96 times square root 0.24 over 0.03 n squared. So when I squared it, the sample size of it 1024.426. So here we need to make the minimum number of people for it. So at least 1025 people. Do we call it people? Yeah, people should be polled. Yeah. In order for there to be greater than 95% chance, blah, 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 blah.